So this is the third part of the lecture on non-experimental designs that you will find out there in the world of educational research. And I'm going to talk in this part of the lecture about a little bit more about relationships, and then survey designs, and finally using secondary data that's available out there in the world. So you'll remember that when we study relationships, we're talking about correlations. And that means that variables systemically vary together. There's a relationship in the ways that they go up and down. So some examples are, there's a relationship between engagement, how engaged someone is in a task, and how much time they will spend on that task. And it's a positive relationship. So across the continuum of how engaged a person is, from very little engagement to very high, and their time on task, the time on task goes up as the engagement level goes up. Another relationship, grade level goes up, or as children get older, their physical activity level usually goes down. Anxiety, what I'm talking about here is very dangerous levels of anxiety, not just the butterflies in the stomach. But as that kind of anxiety goes down, performance goes up. So in my lecture about descriptive statistics, I showed you scatter plots. And this is showing the same information on a scatter plot. So if we put engagement across the x-axis, across the horizontal axis, time on task is on the y-axis, and we look over to the right, which would be people who are very engaged, their time on task is very high. Those more to the left who are not as engaged, their time that they spend on the task is lower. Now, the next example, grade level, as people get older and their physical activity going down, is what we call a negative relationship. Doesn't mean it's a bad relationship, it's just showing us the direction of the trend. So on the left are the younger students, and their physical activity level is quite high. Moving to the right, these are the older kids, and their physical activity level gets lower. And then you see that anxiety and performance is the same. It's a negative relationship. So as you move to the right and people become more anxious, their performance drops and is not as good as those to the left whose anxiety is lower and their performance is higher. When we study relationships, we are on the right track to find some causes. If there's no relationship, there's definitely not a cause there. For example, we've never done experimental studies with smoking and lung cancer. We haven't randomly assigned people to an experimental group that smoked and a control group that didn't smoke, and then tracked whether they got lung cancer or not. But the relationships that we have the data on over years and years and years of collecting data from people who smoke and how much they smoke across the horizontal axis, and that relationship to the incidence of lung cancer is so strong that the world basically accepts that smoking is one of the major contributing factors for lung cancer. So there's not been experimental data for this, but the relationship is so strong that we're able to use it. And then, as I said in my last lecture, we also use relationships to predict what's going to happen in the future. Remember that we talked about this during descriptive statistics. But you're going to find this information in the results sections in articles, and it can really make your eyes glaze over. But you need to force yourself to plow through it and try to understand as much of it as possible. In correlational designs, you will be looking at whole charts that show the correlation coefficients for the relationship. And remember that that correlation coefficient, it varies between -1 all the way to +1. It tells us how strong that relationship is. So that's pretty straightforward and easy to understand. If it's close to 0, there is no relationship there. And the signs tell you how the relationship varies or what the direction of that slope or trend is. So you can picture that in your mind, whether the slope is going down to the right or up to the right. When you read through the results, you need to keep in mind the reliability and the validity of the instruments that are used to collect the data. If those instruments aren't reliable, you cannot trust that the relationship is really there. Or the researcher may say that she didn't find a relationship, but because the instruments used were so unreliable or not valid for what was being measured, that there really is a relationship there. And that's called attenuation. It's called error when you simply can't trust the relationship because they're not reliable. But if you don't find a relationship, that's called attenuation. It's been watered down so much that you can't find the actual relationship that's there. Remember that a relationship does not indicate cause and effect. And some examples: height is positively correlated with weight, but height does not cause your weight. I am a good example of that. SES, socioeconomic status, does not cause achievement. It's related to achievement, and there have been a lot of studies done on that, but socioeconomic status does not cause your achievement level. And SAT scores don't cause your success in college. They have a relationship with it and they predict it very reliably, but they do not cause the success or failure in college. Some look-fors when you are critiquing correlational studies. First of all, look to see if there is a variability in the scores that are being measured. If the scores don't vary, they can't vary with the other variable. I repeat that. If there's no variety in the variables, then they can't change with the other variable. An example would be if you were trying to do a correlational study on height and weight with all NBA players. You're going to be using a group of very, very tall people. And you may not find as strong a relationship as if you could start from those of us who are short on up and look at our height and weight. So if the sample being used is very narrow and restrictive, then the relationship is not true. You don't have the right things there. And that gets back to skewness. Remember, if all the students have really low scores or all really high scores, it's pretty hard to confidently say that those scores are varying as your that the scores vary along with whatever your independent variable is. Kurtosis, remember that we were talking about the bell-shaped curve, and kurtosis means that there's a very restricted range of scores. So when you're looking at correlational studies, look for the standard deviation. If the standard deviation is really, really small, that means that those scores are not spread very far from the mean. Remember that the standard deviation is a measure of how far the scores are on average from that mean, how big that space is as they're stretched out along that axis. So if you see a larger standard deviation, that's a signal to you that there's good variability across those scores. Look also for unusually large sample sizes. It is simply a function of the statistical analysis that when you get really large sample sizes, you are going to find a relationship. You can find almost any relationship if your sample is large enough. That's just the way the statistics work. So if you see sample sizes of greater than 200 subjects, you need to approach that with a lot of caution. Also, going along with that, if there are a lot of variables being analyzed in a multiple regression and there's a ton of variables being used, Well, yes, if you get enough variables in there, you are going to be able to explain the variance with the combination of variables. And that's not going to give you useful information. So always look for that and make sure it's within reason. Also, look for possibilities of other relationships, and the researcher should provide some of these too. There can be extraneous or third-party variables. So, for example, we know that a student's attitude is related to their achievement, but we don't know that it's straight through attitude to achievement. Perhaps their parental involvement and their home background is related to their attitude. And perhaps their parental involvement and their home background is related to achievement. So that means that attitude and achievement seem to have a relationship, but maybe they don't. Maybe it's the parental involvement that's really making the connection there. There can be spurious correlations and strong ones, and that's what we call it when these third-party variables are really what's causing it, but we see the correlation between two that are not meaningful at all. For example, in Las Vegas, you could run a really strong correlation between the number of churches we have in this valley and the number of casinos we have in this valley. Well, that's not meaningful at all. There's obviously other strong relationships that explain the number of churches we have, and there are strong relationships that explain the number of casinos we have. But because the two would vary together, that you could find a spurious correlation there. Now, when correlations involve time, like a predictor, you should look for two variables should vary within a reasonable amount of time. So, for example, if there's a relationship found between SAT scores and income at age 50, that's really kind of ridiculous because there are too many intervening variables in that span of time. So you wouldn't put very much confidence in that relationship. So you need to make a judgment about whether the time is reasonable or not. Now, when a research study gives you the correlation coefficients, they're going to also give you the statistical significance. What that means is, statistically, is that coefficient statistically different from zero? Remember, zero means no relationship. So is that number, that 0.3 or 0.6 or 0.8, is it statistically different from zero in that sample? If the answer is yes, then a statistical relationship exists. And you will see this most often written as I've got it here on the slide. R, Pearson's rho, okay, so it's usually an italicized R. In this case, R equals 0.35, comma, P is less than 0.05. That would be a very common statement that you'll see in the results section. This means, let me translate this for you now. The correlation coefficient is 0.35. So we know from the descriptive statistics lecture that that's a low to almost moderate relationship there, and it's positive. So as the horizontal axis, as we move along that way, the slope is going to be going up to the right. The next part of this statement means that there is a 5%, that's the 0.05, probability that this is simply due to chance and there's still no relationship there. 5% probability. So it is statistically significant because 5% is the threshold that the researcher has set, and that's acceptable. We're willing to say with confidence that there's only a 5% chance that this is just meaningless and that there's nothing there. So in this case, that 0.35 would be statistically significant or statistically different from 0. Now let me flip that around a little bit and show you just the opposite. So remember, we're asking, is the coefficient statistically different from 0 or no relationship? In this case, R equals 0.35, P equals 0.21. So the correlation coefficient is the same. It's 0.35. That's low to almost moderate. But in this case, the researcher found that there's a 21%, that's the 0.21, probability that this is simply due to chance and there's no relationship there. That's too high. That's unacceptable. And so we say it is not statistically significant, and that correlation is not statistically different from 0. Then we look at the practical significance. Those numbers don't mean anything if it doesn't mean anything. So what we want to do next is find out if the relationship is practically significant. Is it going to make any difference in the world? And for this we use what's called the correlation of determination. And that's usually written as the R squared. And that's all it is the correlation coefficient squared. So if the correlation is equal to 0.63 and the probability is less than 0.05, we know that that's statistically significant and it's reasonably strong. But what does it mean? That's where I look at my correlation of determination. So I take the 0.63 and I square it, and when I do that, I get 0.3969. That's 0.63 times 0.63. That's my correlation of determination. So let's put this into some kind of context. If I find a relationship between time spent studying in a group study time, and achievement on a math test, and that correlation, that relationship is 0.63 with a probability of less than 0.05, that tells me that as students spend more time in a study group, their test scores are higher. But I want to look at the practical significance, and that's where I use the correlation of determination. And that's when I find out that 39.7%. You see how I took 0.3969 and changed it into a percent? 39.7% of the variability in those students' achievement scores, their math test scores, is explained by the time they spent in group study. That is pretty impressive if I actually found this. I've just made these numbers up, okay? Don't feel like this is an actual research study. So that's the practical significance lets me say with a percentage how much I'm explaining one variable with the other. Now let's look at the opposite. I gather a bunch of data on how much oatmeal each student consumed for breakfast. And I guess I've got a big enough sample size because I find a statistically significant relationship with their physical fitness test that day. And it's statistically significant. You see, it's the correlation is 0.17, which you know is very, very low. But in this case, it was practically significant, or it was statistically significant. There's less than a 5% chance that that is bogus and there's no relationship there. So then I look, but I want to know if this is really practical in the world or meaningful. So I square that correlation coefficient and I come up with 0.0289. That means that less than 3% of the variability in their physical fitness test is related to or explained by the amount of oatmeal they ate. That's not much to get a research prize over. And that lets you, even though it looks like it's statistically significant, and it is, that isn't where it ends, because you have to look at whether that's really practically significant and meaningful. Now, when you're critiquing correlational studies, you need to look for some specific things. Remember, there should be no inference or conclusion of causation. I can't say that enough. Correlation does not mean causation. And think back to SAT scores do not cause your GPA in college. You need to look and see if the correlation makes sense. Just look at it as a skeptic. Could there be some alternative factors? Could there be a spurious correlation going on where the real relationship is with other factors, but then that makes two variables look like they're related when they're maybe not necessarily? Look very carefully at the sampling procedures, especially because you can't, with confidence, generalize any conclusions out to another group if that sampling wasn't done well. Look at the data collection procedures, and those should be spelled out really well so that you can look at technical aspects of it. Make sure that there's a good variability of scores. Something can't vary if there's not variability there. And are the instruments reliable? And are there indicators given that those instruments have been tested for reliability? Then, if there's no practical significance given, you look at it and you figure it out, because you will find studies that are celebrating a statistical significance, but if you square that and you look at the practical significance or the coefficient of determination, you're going to be amazed that there's no practical significance there, and this should never even have been published. You also need to look at the size of that coefficient, the correlation coefficient. Is it strong enough for the conclusions that the researcher is making? If I'm celebrating and being so excited about a relationship that I've found, but it's a very small relationship, I better back off and be a little more cautious about those conclusions that I'm made. And predictions should always be followed up with prediction studies. So if I'm using a correlation or a relationship to predict what's going to happen, I better follow up with that and see if my predictions really held true. And going back to the very common example of SAT scores and college success, this has been followed up for so many years that we can be really confident that those SAT scores are good predictors. Now, sometimes it's really hard when you start looking at research to know whether it's correlational or it's comparative. Because remember, they're both about relationships and whether the differences are there because of the relationship or not. So some clues so that you can figure this out. If it's a correlational study, you're probably going to find Pearson's R. And that's that correlation coefficient. That's going to be the most common. And it's going to give you the strength and direction, the magnitude and the trend line for that relationship. Very often in a correlational study, especially once you get into multiple regression, remember that you'll see beta weights, and those give you the contribution of each variable in explaining what you're seeing in the outcome variable. Now, if it's a comparative study, ex post facto, comparative causal, ex post facto, you're going to see some different results. You're going to see t-tests reported. And a t-test is when we look at the mean of two different groups and we determine whether that mean is statistically different for each group. So we're just comparing two. If we've got more than two groups, then you're going to see the results of analysis of variance, or ANOVA, reported. And once again, that's looking at the difference between the means of the different groups, and is there statistical difference? The numbers can be different, but is it statistically significant when you look at the difference of those? So those will help you decide whether a study is correlational or comparative. Now I want to talk a little bit about surveys very quickly here. Surveys are incredible tools for getting at descriptive kinds of things and helping us understand. We survey everything you can imagine out there in the world, and you hear a lot about this. Even in the popular press, you hear about surveys. Surveys are wonderful tools because they can be very flexible, they're efficient, and if your sample is right, you can generalize from your sample to the population. In your textbook, there's a section about conducting survey research, and it spells out the steps that you should go through when you're developing a survey. Pay particular attention to that and flag it so that you are comfortable with those different steps in developing and running a survey. Really note the letter of transmittal. Sounds like a fancy name, but really all it is a way to let the respondents you want know what's going on and why you need your input. And if your transmittal letter is above their reading level or sounds all highfalutin, they're going to throw it in the garbage. You're not going to get very good response. And then in your textbook, please take note also of the section about online surveys and some of the pros and cons to that. Online surveys are incredibly powerful, but there's also, you have to really be cautious when you interpret those because the people, I mean, it's the same as Facebook. You don't really know who you're talking to unless you know the person. When you're looking at surveys and critiquing them, you need to look at what the researcher says about their non-respondents. Is there a pattern? Did they send out a survey and 80% of the respondents were male? Why? You know, that's a pattern. You need to look for that. Or were 75% of the respondents over the age of 62 or something like that. You need to look for those kinds of patterns and then start questioning, why did that happen with this particular survey? Surveys need a really good design if you're going to pull the information out of them, and it's not easy to develop a good survey. I've talked about this previously, and I've got the word pilot there in bold letters. If you're going to do survey research or you're reading about survey research that was done, that survey better have been piloted and tried out and run for reliability and validity and all of those kinds of things if you're going to actually trust the results. On the good design portion of it, I just thought of something that really irritates me these days. It seems like about half of the websites that I hit, as soon as I hit their website, up pops a little window that says, would you take a minute to take our survey and give us feedback? And it really ticks me off because I don't even know if their website's any good yet, and yet they want my feedback on it. I don't know if my experience on their website's going to be any good. How can I answer the survey before I've hit their website? So that drives me nuts, and I always close those out. So I've got a feeling they've got a little bit of a problem there with their design and how they're approaching me online. I probably ought to take one of them and see what it's like so that I know if you can actually give them some information about their website, shouldn't I? The transmittal letter really is critical, and sometimes incentives will have been given for people to respond to the survey. Have any of you received that letter in the mail that's got a crisp dollar bill glued onto it so that I think they're trying to guilt us into responding to their surveys by giving us $1, and I'm not sure that helps or not, but sometimes it will help. Incentives like in this class you were supposed to be, as part of your grade, you're supposed to participate in a research study. I guess that's an incentive. But please remember that I've given you an alternative assignment that really shouldn't be onerous on you or time consuming, and you can do that instead because there simply are not research studies available out there this semester. Just a quick word about secondary data. This is what we call when a researcher goes in and uses existing data that's available somewhere. So one example of this is our national or international databases like the NAEP. All of that information from the NAEP and the PISA tests are available to researchers. And those databases are just so large, it's hard to even imagine. One example is the Early Childhood Longitudinal Study. And this has studied children from early ages clear on through. And the data has already been collected, it's already been coded, and the sample sizes are huge. And usually these databases are free. Sometimes you do have to pass a certification test or take training specific to the database to know how to use it and extract the data. So there are some incredible benefits for using secondary data. The subjects, for the most part, have been de-identified. So you don't have to worry as much about anonymity or protecting privacy. The data already exists, and a real benefit to this kind of data is that previous and other researchers have done some incredible things with these databases and can give you ideas and start the juices flowing. You do have to consider some things. For some of the databases that exist out there, you do need you need technical training or certification, and some of them you may have to pay for, but most of them are free. The data may not be very accessible. It sometimes has to be extracted, and it sometimes takes specific software to be able to pull it out and then analyze it. It's not like you can plop it always into a spreadsheet or into a tool like SPSS. Some of them are very specific to tools that are used. You also have to look carefully at the documentation because a lot of this is coded. You'll have a variable that has a name that just doesn't make any sense, and you need to look at the manuals and the documentation to know what was truly measured in that variable and what the coding means. What does a 1 mean? What does a 2 mean? Etc. Remember those nominal scales that we talked about in categorical data. And then you still have to be concerned and follow the rules of that data set for privacy safeguard purposes. Now, one that I wanted to make sure that you're aware of in the state of Nevada is that we have what's called the Nevada Report Card. And inside that, there's an incredible amount of data on students in our state. CRT scores going back at a school. You can disaggregate it by ethnic groups and ages and free and reduced lunch and languages spoken at home. So there's some interesting data in there that you can get right within our own state. I want to finish up by just talking a little bit about the assignment for this week. Your assignment this time actually spans 2 weeks. It's not technically due for 2 weeks, but it's kind of complicated. So I want you to get started on it and understand clearly what's going to be expected of you. And don't hesitate to text me or email me if this is confusing. The instructions are posted for you. But there's an article, a research article that I'm going to ask you to read. And then there are a minimum of 3 postings you will need to make for full points. First of all, you're going to critique just pick one technical aspect from that article. And it was not in your syllabus, but I'm going to beg you to do, and I will post an alert to this also, to make that due by October 18th. So make that due by the end of the first week, because each of you then need to read another student's post and choose someone who posted about a different technical aspect than you did and respond to that post. So that's why I'm asking you to each get your posting about the technical aspect up at the end of the first week so that you each have the second week to respond to someone else. Then you need to do a third post that actually gives us your thoughts and opinions about the application of the information that you found in that article. And do that from an educator or policymaker perspective. So you can do that anytime during the 2 weeks, your thoughts on the application. And of course, as always, you're welcome to read each other's posts about thoughts on the application and respond to each other. So that will be the assignment for this next section.